Imagine waking up tomorrow and finding a robot that can run faster than you, carry heavy loads, understand your voice, learn from what it sees, and even work beside you. That future isn't decades away anymore. Companies are already building machines that can walk, jump, climb, balance, and perform tasks that once required humans. From Unitree's insanely agile robots to Tesla's ambitious Optimus and Boston Dynamics Atlas, these machines are pushing robotics into a completely different era, and some of them are far more advanced than you might expect. So today we're counting down 10 of the most incredible AI-powered robots you need to see. Forget everything you thought a robot dog was supposed to do, because the Unitree AS2-W takes the idea in a completely different direction. At first glance, it looks like a compact four-legged robot, but each leg is fitted with a powerful 7-inch motorized wheel, letting it roll across flat ground at more than 21 miles per hour. And when the terrain gets rough, it can switch from wheels to walking, climbing, or even crouching to squeeze through spaces as low as just 21 centimeters tall. This 25-kilogram machine can tackle slopes as steep as 45 degrees, climb steps up to 30 centimeters high, and clear obstacles reaching 80 centimeters. But the numbers get even crazier when you look at its strength. While standing still, the AS2-W can support up to 150 kilograms, and it can continuously carry around 16 kilograms while moving. Inside, reinforcement learning software constantly adjusts its movement and balance, instead of simply following a fixed route. With over 3 hours of unloaded operation, a range exceeding 30 kilometers, and a quick swap battery, this isn't just a robot designed to look impressive. Unitree is building it for inspections, security patrols, logistics, and search and rescue missions. Places where wheels are fast, legs are useful, and sometimes you need both. Then Unitree takes things to an entirely different level with the H2, a full-sized humanoid robot standing around 5 feet 11 inches tall and weighing roughly 70 kilograms. Unlike the company's earlier H1, which was built heavily around speed, the H2 is designed to move and interact more like a human. It has 31 degrees of freedom across its body, including highly articulated arms, legs, waist, and head, allowing it to walk, crouch, balance, turn, and manipulate objects with far more natural movement. Its legs can produce up to 360 Newton meters of joint torque, while each arm can continuously handle around 7 kilograms and reach a peak payload of 15 kilograms. But the really interesting part is what's happening inside. The H2 separates its motion control computer from a dedicated development computer, while upgraded versions can support NVIDIA Jetson modules, including the Jetson AGX Thor, reaching up to 2070 TOPS of AI performance. It also uses binocular depth vision, microphones, speakers, Wi-Fi 6, and a removable 972 watt-hour battery capable of up to 3 hours of operation. And with a starting price around $29,900, Unitree isn't presenting the H2 as a distant science fiction concept. It's positioning a human-sized robot as a platform for research, interaction, and eventually real-world work. There's a robot that could completely change the conversation. Meet the Tesla Optimus. Standing about 5 feet 8 inches tall and weighing roughly 57 kilograms, Optimus is designed to work in environments built for humans without requiring factories or homes to be redesigned around it. But what makes Tesla's approach especially interesting is that Optimus isn't supposed to simply follow a list of pre-programmed movements. Tesla is building it around the same broader AI philosophy used in its vehicles, allowing the robot to learn from visual information and adapt to physical tasks. The latest hand design is particularly impressive, with dozens of independently controlled movements and tactile sensing intended to give its fingers much finer control. That could eventually allow Optimus to handle objects that would be difficult for a conventional robot, from delicate components to tools and other everyday items. Tesla has also demonstrated the robot performing repetitive factory tasks while continuing to train it using real-world data. The goal is ambitious: a general-purpose machine capable of doing boring, repetitive, or potentially dangerous work for hours at a time. And with Tesla working toward large-scale production, Optimus could become far more than another impressive robot demonstration. If Tesla can actually deliver on that vision, this may be one of the machines that determines how quickly humanoid robots move from research labs into everyday industry. If there's one humanoid robot that has been making people question what machines are actually capable of, it's Boston Dynamics' Atlas. The company has spent years making robots that could run, jump, flip, and balance in ways that looked almost impossible, but the new electric Atlas represents a very different goal: putting that physical intelligence to work. Standing around 1.9 meters tall, Atlas is built at human scale, allowing it to operate in spaces and workflows already designed for people. Instead of relying on the hydraulic system used by earlier versions, the new Atlas uses powerful electric actuators designed for more precise and practical industrial operation. Its body is highly articulated, giving it an extraordinary range of movement, while its AI-powered control system allows it to understand its surroundings, maintain balance, and manipulate objects without every movement being manually programmed. Boston Dynamics is also working with Hyundai and other industrial partners to bring Atlas into real manufacturing environments. That shift is what makes this robot so interesting. This isn't just about making a machine perform a spectacular backflip for a viral video anymore. The real test is whether Atlas can repeatedly pick up parts, move materials, adapt to changing situations, and keep working inside a real factory. If it can, Boston Dynamics may have finally turned one of the world's most famous research robots into a genuine industrial worker. Now imagine a humanoid robot that isn't designed to look like a machine from a factory, but something that could eventually exist inside your home. That's the idea behind Figure 03. Standing roughly 5 feet 6 to 5 feet 8 inches tall and weighing around 60 kilograms, this third-generation humanoid was redesigned with mass production and real-world interaction in mind. It can carry up to about 20 kilograms, operate for several hours, and move at roughly 1.2 meters per second. But its most important upgrade isn't its speed or strength, it's the AI. Figure's Helix system is designed to connect what the robot sees with the actions it takes, allowing it to perform tasks without engineers having to manually program every individual movement. Its cameras give it a wider, faster view of the environment, while cameras built into the palms help it see objects when its hands move into tight spaces. Then there are the hands themselves. Equipped with highly sensitive tactile sensors designed to detect tiny changes in pressure and grip. Figure has demonstrated robots learning tasks such as folding laundry, handling dishes, and sorting objects, pointing toward a future where a humanoid could potentially learn new jobs simply by watching and being instructed. And with wireless charging and fleet learning technology being developed around the platform, Figure isn't just trying to build one impressive robot. It's trying to create an entire generation of machines that can learn, improve, and eventually work alongside us. Most robots are built to stay behind a safety fence. Agility Robotics Digit is designed around a very different idea: a humanoid that can actually work alongside people. Built primarily for warehouses and industrial environments, Digit uses its human-like legs and compact body to move through spaces that already exist instead of forcing companies to redesign their facilities. It can carry loads of around 35 pounds, move at roughly 1.2 meters per second, and is designed for long operating periods with rapid battery recharging between shifts. But the interesting part is how Digit is built for real warehouse work. Its arms use standardized interfaces, meaning the robot can potentially switch between different tools and attachments depending on the task, from moving containers to handling smaller items. A wide sensor system gives it awareness of people and obstacles around it, while its software can connect with warehouse management systems to coordinate tasks across a fleet of robots. And if Digit loses its balance, it can recover and get back on its feet without someone having to walk over and reset it. That's the bigger idea behind Digit. Not a robot built to perform one spectacular demonstration, but a machine designed to become another worker on the warehouse floor. If humanoid robots are going to become genuinely useful, this is exactly the kind of problem they need to solve. What if the robot wasn't just doing the job, but actually helping teach the next generation of robots how to do it? That's where Apptronik's Apollo 2 gets seriously interesting. Standing around 5 feet 8 inches tall and weighing roughly 72 kilograms, Apollo 2 is designed for industrial work, with the ability to handle loads of up to about 25 kilograms. Its modular design can also be adapted for different environments, including a walking configuration or a wheeled mobile base. But Apollo 2's biggest role may be happening behind the scenes. Apptronik is using physical robot deployments as a way to collect enormous amounts of real-world data. How a robot sees an object, moves toward it, grips it, reacts to unexpected situations, and completes a task. That data can then be used to improve the AI controlling future machines. Apollo 2 is built around Apptronik's Artemis software platform and has been developed alongside Google DeepMind's robotics work, creating a fascinating feedback loop between physical machines and artificial intelligence. Its hot swappable batteries are also designed for long operating schedules, potentially allowing robots to keep working while depleted batteries are replaced. So Apollo 2 isn't simply another humanoid waiting for its turn in a factory. It's part worker, part experimental platform, and a part teacher, helping train the intelligence that could eventually power thousands of robots like it. This might be one of the most surprising robots in the entire lineup, because the Unitree G1 looks relatively small and simple until you see what it can actually do. Standing only about 1.32 meters tall and weighing around 35 kilograms, the G1 is compact enough to fold down into a package that can be carried by one person and even transported in a car. But don't let its size fool you. Depending on the configuration, it can reach speeds of around 2 meters per second, recover from sudden impacts, jump, perform a side flip, and even launch itself back onto its feet from the floor. The G1 uses sensors including 3D LiDAR, depth cameras, joint encoders, and an IMU to understand its surroundings and track its own movement. Its onboard computing can also be upgraded for running AI models directly on the robot. And unlike many experimental humanoids that exist mainly inside research labs, Unitree positioned the G1 as a relatively accessible platform for robotics development, with the base model starting around $16,000. The EDU version goes much further, offering more degrees of freedom, dexterous hands, developer access, and support for tools like ROS2, Python, and C++. That's what makes the G1 so interesting. You're not looking at a giant futuristic machine that costs a fortune just to experiment with. You're looking at a compact humanoid platform designed to put advanced robotics into the hands of researchers, developers, and students. And now we reach the robot that could make humanoid robotics feel much less like an exclusive technology for giant companies. Meet the Unitree R1. Standing around 1.2 meters tall and weighing roughly 25 to 29 kilograms, this compact humanoid was designed to be portable, agile, and dramatically cheaper than most robots in its class, with the base model starting around $5,900. Despite that small size, the R1 has 26 degrees of freedom, stereo depth vision, multiple microphones, speakers, and sensors that constantly track its position and movement. But its real party trick is mobility. Unitree describes the R1 as being built for sport, and demonstrations show it performing movements including rapid push recovery, cartwheels, handstands, and fast dynamic motion. Its onboard AI can also understand voice commands, recognize images and gestures, and handle conversations with Unitree's UniFO-LM system designed to run directly on the robot. The standard version keeps things simple, even using fixed hands rather than expensive dexterous fingers, but the R1 EDU and Pro versions open the platform to developers with additional computing, SDK access, simulation tools, and expandable hardware. And that's why the R1 could be important. It's not trying to be the strongest or most sophisticated humanoid here, it's trying to make people ask a much more interesting question. What happens when humanoid robots become cheap enough for ordinary developers, schools, and enthusiasts to experiment with? And to finish the lineup, we go back to the robot that helped put Unitree on the map, the H1. This is a full-sized humanoid standing around 1.8 meters tall, yet it weighs only about 47 kilograms. But what really made the H1 famous is what happens when it starts moving. Its standard walking speed is around 3.3 meters per second, while a specially modified performance version has reportedly reached an astonishing 10.1 meters per second. That's more than 22 miles per hour on 2 robotic legs. Underneath that frame are powerful permanent magnet motors capable of producing enormous joint torque, while real-time balance algorithms allow the robot to deal with uneven ground and sudden disturbances without simply falling over. The H1 also combines 3D, LiDAR, depth cameras, and onboard computing to perceive its surroundings, while its developer-focused architecture supports ROS, SDKs, and optional AI hardware for advanced experimentation. A quick swap battery provides more than 2 hours of operation depending on how hard the robot is working, and its modular design can support more capable robotic hands for manipulation. But the most impressive thing about the H1 isn't any single specification. It's what the machine demonstrated about the future of humanoid robots. A relatively lightweight machine can move incredibly fast, stay balanced on 2 legs, and perform movements that only a few years ago looked impossible. And if this was where Unitree started, the question is obvious. How far can these machines go next? And that's where robotics is heading. And honestly, we're only getting started. If you enjoyed seeing what these incredible machines can actually do, make sure to subscribe to Mevron Tech and support the channel. We've got a lot more insane technology, futuristic machines, and groundbreaking inventions coming your way. Thanks for watching, and we'll see you in the next one.